Hey Bulldogs! So today I got a couple emails from students asking about the problem on the homework where you had to solve a quadratic equation. You guys seem to be good with factoring, but solving, we're saying we're having a little troubles after watching the notes video and understanding everything. So I wanted to back up and just explain a couple things to you guys and go through some examples. Okay, so this is the quadratic equation that's in your notes that we used in the notes video, y equals 2x squared plus 5x minus 12. When we're solving a quadratic equation, what that means is we're looking for the x-intercepts. And those x-intercepts are the roots. So we're looking for the place where the quadratic equation crosses the x-axis, where that graph crosses the x-axis. Okay, so let's just say this is the graph of our quadratic equation. I cross the x-axis here, I cross the x-axis here. Whenever we are crossing the x-axis and we're writing out the coordinate of those points, whether it's a linear equation, a quadratic equation, a cubic equation, no matter what the equation is we're working with, whenever we cross the x-axis, our y value is 0. See, the coordinate of this point on the left here is some x number, we don't know what it is yet, and 0 for y. And the one on the right, it's some x number and 0 for y. So when we solve a quadratic equation and we're looking for those x-intercepts, that means we're setting y equal to 0. So on your homework paper, you have a quadratic equation to solve and it's already set equal to 0 for you. See, so we're setting it equal to 0. We're finding the x values that make y equal to 0, okay? Now, to do that, what we need to bring into play is that zero product property that the notes video talked about, okay? We know how to rewrite this quadratic equation in terms of its factors. We know how to factor that if it's factorable, which it is. So we're going to do that in a minute. Once we factor it, now we have a product that's equal to 0. If we have a product that's equal to 0, one of the factors must be 0. So that means either what's in this parenthesis must equal 0 or the second parenthesis must equal 0. So let's figure out what those factors are. To do that, we're just going to use our area model and a diamond problem. Okay, so we factored the quadratic expression. It factors into 2x minus 3 times x plus 4. This is a product that equals 0, so that means either 2x minus 3 equals 0 or x plus 4 is equal to 0, okay? Remember, anytime we have two things multiplied together and the result is 0, one of them has to be 0. One of the factors has to be equal to 0, okay? So if it's the 2x minus 3 that equals 0, well, we're just solving that equation to figure out what x would be. So add 3 to both sides. 2x is equal to 3, divide by 2, x is equal to 3 halves. Or if x plus 4 is equal to 0, then when we subtract 4 from both sides, that means x has to equal a negative 4 to make that happen. You can even take those answers for x, plug them back into the parentheses and see what happens. See, if I plug in negative 4 into these parentheses, it makes the second parenthesis equal to 0, which would make the entire product be 0. Or if I plug 3 halves into the first parenthesis, it will make that first parenthesis equal to 0, which will make the entire product equal to 0. So solving the quadratic equation means finding the x values that will make the equation equal to 0 because that's where the x-intercepts are, or the roots, and that's what we're trying to find. The next problem I want to work through with you is this one. We're going to solve 2x squared minus 16x plus 30. we're going to solve that quadratic equation. So we're going to set it equal to 0. Okay, so if we are asked to solve a quadratic equation, what we need to do is we need to factor it. Okay, so the first thing I'm going to ask myself is there a greatest common factor that I can pull out of each term? And in this case, there is. Okay, each of these terms is divisible by 2. So I'm going to pull out a 2, and I'm left with x squared minus 8x plus 15 is equal to 0. Okay, this can be factored further. So now we're going to take a look at an area model and a diamond problem to help us out. Place my first term and my last term. The product I'm working towards is 15x squared. The sum is a negative 8x. So if I think about what multiplies to give me 15x squared and adds to give me negative 8x, it's negative 5x and negative 3x. That is what goes in the 2 empty boxes in my area model. Now I'm finding the dimensions. I need an x and an x to make x squared. I need a negative 5 here to make the negative 5x box. And I need a negative 3 here to give me a negative 3x in the top right box and a positive 15 in the bottom right box. Okay, so x squared minus 8x plus 15 factors into x minus 5 times x minus 3, and I still have that greatest common factor of 2 on the outside that I pulled out, and all of this is still equal to 0. All I did was take what's in the first line and rewrite it in a different form, in its factored form. Okay, now, if I have a product and it's equal to 0, what that means is one of the factors, one of the things I'm multiplying together must equal 0. Can't be the 2, that's not going to change. 2 is always going to be 2, 2 will never be equal to 0. But I could make the x minus 5 equal 0, or I could make the x minus 3 be equal to 0, depending on what I put in for x. Okay, if I add 5 to both sides, I will get x is equal to 5 for my first possibility. Or if I add 3, I'll find that x is equal to 3 is the other value of x that'll work. And again, put that back in, okay, anywhere you want, any form of this equation. If we put it in right here in the factored form, if I put 5 into this equation, the first parenthesis is going to equal 0. The entire product is going to equal 0, okay? Because I'll have 2 times 0 times 2, because 5 minus 3 is 2. If I plug in 3 right here, okay, then the second parenthesis is going to equal 0, which will make the entire product 0. Even if I take these and plug it in all the way back up here, let me switch colors for you, okay? Let's check the 5. If I take 2 times 5 squared minus 16 times 5 plus 30, the question is, will that equal 0? Let's check this out. Okay, 5 squared is 25 times 2 is 50 minus 16 times 5, which is 80, plus 30. Does that equal 0? Yes, it does, okay? These are the two numbers that will make the quadratic equation equal to 0, which means it makes the y value 0, which means we're crossing that x-axis. So this quadratic equation crosses the x-axis here at 3 and here at 5, okay? And if we wanted to keep graphing it, we could figure out where that vertex is. It's going to happen right in the middle here at 4, so we would plug 4 in and figure that out. All right, let's do that. We'll just keep on going and graph this. Okay, so I don't know if everybody caught that, but the vertex is right in the middle of the two intercepts. So right in the middle of 3 and 5 is the number 4. Okay, that means my vertex has an x-coordinate of 4, okay? And so to find the y-coordinate, Well, I just plug x into the equation. Okay, I plug 4 into the equation for x. So the y value comes from taking 2 times 4 squared minus 16 times 4 plus 30. Okay, well, let's simplify that. 4 squared is 16. 16 times 2 is 32. Let's see here. Minus 16 times 4, which is 64, plus 30, which means y equals a negative 2. Okay, so what does that tell us? Well, the x-coordinate of the vertex is 4, the y-coordinate is negative 2. Boom, right there. There's my parabola. All right, so hopefully those two examples helped you out a little bit to understand what we're doing when we solve a quadratic equation. Okay, what that means to set it equal to 0 and how we come up with those x values that make it equal to 0. And also that connection between those x-intercepts and the graph and solving and factoring in zero product property, all of that. If you have any questions, I can set aside some time tomorrow to meet with you. In the morning, I have time set aside to meet with students by appointment. I do have some meetings scheduled for the afternoon, so I'm not as free in the afternoon. Although we can see, send me an email if you're having troubles, and let's shoot for sometime between 10:30 and noon to schedule a time to meet up if this is something you're still struggling with after watching this video. Okay? All right, good luck.